Hey Math 20-1 students, we're looking at lesson 6.4b, applications of rational equations. So this is all about writing the equations, and then we're going to actually switch to the graphical approach for solving each of these answers. So that's just a different way to solve rational equations. So for example number 1, we're going to find the value of two integers. One positive integer is 5 more than another. So we're going to say x represents our first integer. And since the other one is going to be 5 more than the previous, we're going to have x plus 5 being our second integer. What is the reciprocal of the larger number? So the larger number is x plus 5. They want the reciprocal of that. So they're saying when the reciprocal of the larger number is subtracted from the reciprocal of the smaller. Reciprocal is when you flip the numbers and it'll become then 1 over x. And so they're saying that you want to subtract the bigger one from it, from 1 over x, so that'll be 1 over x plus 5. And the result, meaning what it's equal to, is 5 over 14. So what you're going to do in your calculator is you're going to put this as your y1. The left side of your equation can go into y1. The right side of your equation will be your y2. Then you want to adjust your window. We know that they're going to be integers. So we're going to adjust our answer to find the solution. So our window would be for our x's, negative 10, positive 10, and 1, and our y, negative 10, positive 10, and 1. So I usually start there when I'm not sure, but if it's a real life question, make sure you try to make sense of it before you do anything else. So I'll show you kind of what this looks like. Now my graphing calculator isn't really working well, but this is what I did. I put 1 over x. Now, whenever you have more than one item in a level, you want to put brackets around it. So I didn't have to put a bracket around x, but I did have to put a bracket around x plus 5. Otherwise, I would have gotten the wrong answer. So you're going to have 1 divided by x, subtract 1 over in brackets x plus 5. And then your y2 will be the answer, the right side of the equation, which is 5 over 14. You're going to graph it and get something like this. So what you need to figure out is the intersections between, in my case, the blue and red graphs. So one intersection happens here and one intersection happens there. So you would have to go second trace number 5. You would have to move your cursor until you're as close as possible to your intersection. Then you'd press enter. Then you'd use your cursor and you'd move to the other graph by pressing enter again. As long as you're as close as possible to the intersection, then that's all that matters. So your intersection, if you're doing it properly, should actually be negative 7. So when you go second trace number 5, intersection, go as close to the intersection, and just press enter 3 times. So I'm going to write those steps down for you guys. So you're going to graph it. Then you're going to go second trace number 5, which is intersection. You're going to move your cursor until you're as close as possible. And then you're just going to press enter 3 times. And that should have given you an answer of negative 7. So we know that x could equal negative 7 as our first integer, which means that if this is negative 7, our second set, if we add 5 to that, will give us negative 2. So that's one set of solutions, where x could equal negative 7 and the second integer could equal negative 2. Now, if you graph it again, if you look at the graph, there's another solution, so we're going to have to do it again. We're going to have to go second trace number 2. We're going to have to move as close as possible to that intersection by moving your cursor either left or right. And then once you get there, press enter 3 times. Okay, so Again, once you press 3 times, you should find that the answer is 2 there. Now, if you check, what you want to do is you want to put, well, the next solution could be 2, and if we add 5 to that, 7. Now, what I'm going to do is, this is another possible set of solutions. I'm going to cross this solution off. The reason being is it can't be a solution because of this word right here. It says one positive integer is 5 more than the other. Well, those are both negative, so that can't work. So the only solution that could work is if you had 2 and 7. So 2 being the first integer, 7 being the second integer, and if you put it into the equation, it will equal 5 over 14. Example number 2. A traveling salesman drives from home to a client's house 150 miles away. So this is similar to our previous lesson where we did a distance, speed, time chart. So we're going there and then returning. So that's kind of what we're going to split our rows as, going there and then the return trip. So going there and returning, the distance won't change. So they're both going to be 150. Now, at what speed was the salesperson driving on the way to the client's store? So that's going to be our x. So that'll be the speed going to the store. So we're going to call this x. It says on the return trip, he drives 10 miles per hour slower. So you're going to have to go x minus 10. Time is always equal to distance over speed. So you're going to take 150 for the distance and divide it by the speed going there. And 150 divided by the speed returning, x minus 10. So this one is going to take longer because you've slowed down your car. So 150 over x minus 10, subtract 150 over x. That's going to be equal to the time difference between the two trips, which it says you're going to add a half hour to your trip. So you're going to add 1/2 hour to your trip. So you're going to put 0.5 again. And using the graphical approach, I'm going to put this into y1, this into y2. And the window I would use to see this would be, we're talking about the speed going to the store. So we're talking about the speed logically for a car. So we're going to go from 0 to 100 for the speed. And for y, we're talking about this is our y. Whenever you have a constant as y, meaning there's no variables, that's what we have to be able to see. So I'm going to go from 0 to 1 because 0.5 is in between those two numbers. And I'm going to change my scale to go up by 0.1 because when your numbers are small, meaning going from 0 to 1, 0 to 2, you should change your scale to be much smaller. So the first number is always your min, second number is always your max, and the third number is your scale. Okay. So if you put this into your calculator, remember you're putting y1, y2. You're finding the intersection, just like in the previous question, by going second trace intersection. You should get that x equals 60 miles per hour. So that's your answer. The negative one will not make sense. Example number 3. Again, it's a distance, speed, time one, because we're talking about Jerome rowing a boat downstream when the average speed of the current is 2 kilometers per hour. Jerome then finishes the journey in 9 hours. What is Jerome's average rowing speed in still water? So we're talking about this being our x. the average rowing speed in still water. So we're going to talk about going upstream versus downstream. So the Rome rows is about 24 kilometers downstream. And that's going to be the same journey upstream. So 24 kilometers. Now we know that we're talking about the rowing speed in still water. So none of these are in still water. So we're going to use X. But for going upstream, you are going to subtract 2 because you're going to be slowed down by the current. So the current's going to push against you, making you 2 kilometers per hour slower. Downstream is the opposite. Downstream means that the 2 kilometers per hour of the current will actually help you go faster along the river. And then our time column is always our distance divided by our speed. And then our distance divided by speed. So they're saying that they can complete the journey in 9 hours, so that's a total. Whenever they're giving you a total time, you have to add the 2 fractions. So order does not matter in addition. And that's equal to 9 hours. So again, if I want to do this graphically, you're going to put that as y1. This is y2 in your calculator. Make sure you put brackets where I did. If you miss the brackets, you're gonna get a different answer than I will. Then you're gonna press second trace once you've graphed it. Number 5, intersection, and the window that you would need to use to be able to see this current would be 0 to 10, going up by 1, because we're talking about X being the river current. So river currents usually aren't that fast, so that's why I'm setting it from 0 to 10. And then your Y value, so this is your X, your Y value will go from 0 to 15, going up by 1. Now if you press enter, so second trace number 5, once you have number 5, go to the intersection as close as possible to it, and then press enter 3 times. So once you press enter 3 times, you should find that it is X equals 6 kilometers per hour. So that means if you're going upstream, you'd be going 4 kilometers per hour. And then if you're going downstream, you'd actually be going 8 kilometers per hour because of that plus minus 2 for both situations. So that's our speed in still water. Now this is the mowing lawn kind of scenarios where you're going to have the time, the 1 over time, and then you're going to have time together over their individual time. So we know that there's 2 charts or 2 columns, 2 rows again. So we have Kira mows the lawn in 40 minutes. So we're going to put 40 minutes there. Now we can be in minutes as long as everything's consistent. So our previous question in the last lesson was an hour. So we were all in hours. Now we're going to be all in minutes. So when Mark and Kira work together, they can mow the lawn in 24 minutes. That's going to be that time together. So I'm going to put 24 over whatever their individual time is. So for Kira, it's going to be 40. And then we're going to put Mark. So Mark is unknown. We actually do not know. That's the question. How long will it take Mark to mow the lawn on his own? So that's what your X should be. Whatever you don't know and you're trying to solve for, we want to find out how long it will take Mark to mow this lawn on his own, so that's x. So here we're going to have 1 over 40, 1 over x, and then 24 over x. These problems are always the same. You're going to add the two time together over times, and that's always going to be equal to 1. So again, put this into y1, this into y2. Your window that you would use would be 0 to 90, because we're talking about the time it takes to mow a lawn on his own. We already know it takes 24 minutes for them to do it together, so it has to be more than that. So I'm setting it to 90, going up by 1. So that's your x. Your y would be your y would go from 0 to 2, because we know that this is our y value 1. So we're just going to go slightly above it, so 0 to 2, going up by a scale of 0.1. Now if you find the intersection, you should see that the intersection is 60 minutes if you're doing it properly. So check that you get that answer. Our last question, we have antifreeze is added to water to make the solution that is used in automobiles. How much antifreeze must be added to 12 liters of water to make a solution that contains 40% antifreeze? So we have 0.40 as the antifreeze. So we always have to convert to our decimal value. Now, we know that we're going to have 12 liters of water. And what we're going to be doing is we're going to be adding a certain number of antifreeze to the top of the fraction and that exact same amount to the bottom, because that would change our total. And we're trying to get this answer to equal 0.40, which is so what we're trying to put y1 and this is y2. So we're trying to find the intersection. So with our intersection, we want to set our window to go from 0 to 15, going up by 1, and 0 to 1, going up by 0.1. So we just need to pick for the y. This is our y value. Values around 0.40. So that's why I picked 0 to 1, going up by 0.1. And then you should find that the intersection is 8 liters if you did this properly. Okay, so we are trying to figure out how are we going to get 40% antifreeze. So as long as we add the same amount of antifreeze to the top and bottom. Oh, yeah, so antifreeze to the top and bottom, that's why we added an x value. So this is our value of x at the end, 8 liters. And that's it for our lesson. So hopefully you guys are practicing and trying those word problems. So I find the word problems, they are difficult, so just practice, and then as long as you know how to do these kind of main ones, that would be the important idea.